An American professor of quality control was teaching in US. बहुत नजदीक है. So he used to teach in America, universities, MIT, Colorado and all that. He used to teach. And at the same time, in Japan, they were very serious to learn. But other than one professor, there were not many people. So they invited him to Japan, and he taught them how to take care of quality control and cost. And then they very seriously implemented it, which was not done in America. So that is how this came. If they can do, why not we? They found out the reason is that they study, they don't implement. Like, most of our universities in India, whatever is study, I don't think even one person comes to the level of implementation or thinking. Once you get a degree, pass, and whatever use is there for that degree, it's over once for all. There is nothing more out of that. Okay? So when we now look at how did Toyota could do this, it became that they had people as the resource, nothing else. Natural resource they had were only people in Japan. And other thing they had to import. So they found that since the people are good, if they use the concept of low-cost automation where people are involved in the manufacture, not high-fi automation as was done in American universities, they can get a very good return on investment or ROI. That is what they had found out. Whereas in US, the conditions were so bad that when first time flexible manufacturing systems were introduced as an idea by MIT, most of the big companies thought that this is our solution and to get out of the problems, they all bought FMS in large quantities because they did not know how to look at ROI in that case. And instead of giving them profit, they went on sinking the income, and ultimately they had to sell it off at a low price, and they learned the lesson that the cost and quality are not decided by the machines. It is decided by the people. That is the first time they realized this mistake. And for that purpose, Toyota is so good that if any of you like, there is a book called TPS, Bible of Manufacturing Productivity. 3 parts of it. Mechanization means control is done manually, but otherwise the power, actuation, muscle power was provided by the machines. Suppose we have to lift something above 15 kilogram mass, you will be told that by industrial engineering that for a 400-minute shift, if the load is more than 50 kilogram, the person will get tired within the first 200 minutes, and the last 200 minutes the productivity goes on decreasing. Whereas if you use mechanized methods to this lift, beyond 15 kg, the person can be productive till the end of the shift. So that is why mechanization was just removal of the muscle power and control totally done by manually. Beyond that, if you want to increase productivity and competitiveness, the machines used were semi-automatic, where only loading, unloading is manual, and the entire cycle is done by the machine. So this is the first time they realized and found out in the history of manufacturing that now you don't have to say every machine needs a person. Because if loading, unloading is only to be done, one man can take care of 6 or 8 machines. He will load the first one. It will go on working for some time. Go to the second, third, fourth, fifth, go on loading them all. And then by that time he comes back, takes a rest and cup of coffee. Now the loading of the first machine starts. So this was a tremendous advantage in productivity. Because instead of 6 people, 1 person can do it. It is not only the saving of the labor, the saving of the medical expenses, the saving of the investment in the canteen, saving of the investment post-retirement. The benefits was enormous. So then the semi-automatic became very popularly used, whereby a group of machines can be handled by 1 person. And when we go to fully automatic, There is no need of manual intervention in between. So these are called the degrees of automation, as we know. And the nature of automation can be what is called rigid, where the cycle cannot be changed very easily earlier days, when microelectronics had not yet reached to that high level. Whereas if you have got microelectronics and computers which are small enough, then we can have a flexible method of manufacturing and use the programming of the CNC machine. Some of you might have read in the history that MIT, when they produced the first CNC machine to be competitive in the Cold War to manufacture the airplanes, the CNC, the machine tool, milling machine was roughly the size of this table, and the controlling computer was the size of this room. You can imagine the condition. Machine of this size, this table size, needed a computer as big as this entire room. So obviously such a thing cannot work in a shop floor. But fortunately, in between, there was development, condensing size of the computer further and further, further and further. Ultimately, the chips, microelectronics, we changed the whole picture and brought down the size of the computer to a negligible size. When we look from the investment point, that is very important for some of the countries and industries. If you look at India, 80% of the industries, they are small and medium scale. They don't have a very large amount of capability to invest. Whereas some big, huge corporations, they have the power. So they can invest and wait for 5 or 10 years for ROI, the return on investment. But most of the companies, if they invest, they want the return back less than a year. That is the concept. So that was what is called low-cost automation. Whereas if you have the necessary financial strength and market presence, in that case you can afford to go for high cost, where high productivity, efficiency, flexible manufacturing system, and ultimately now the computer integrated manufacturing system can also be used. So from the investment point, as mentioned here, this word came from some Japanese word from Japan in the 1970s. By translation, this says low-cost automation is a technology that creates some degree of automation, not full automation, some degree of automation around the existing equipment, tools, methods, people, all the things that are existing, without making any changes abruptly, whatever is going on, using mostly standard components available in the market. So if I want pneumatics, everything like valves, cylinders, tubes available in the market. If I want mechanical things, gears, shafts, bearings, they are all available. Hydraulics, hydraulic cylinders, power pack, motors, they are all available. So the advantage of developing things with only standard ready-made things is that you don't have to make, you don't have to wait. They are all available within a very short period. Normally 6 to 8 weeks they will deliver because they are already made. And this was found to be a very attractive concept which is useful now. In India also we face a similar condition that investment in a big way is possible only for about 10-15% of the industries, but 80 to 85% of the industries which runs into thousands and lakhs, they can't. They have to be very particular about the amount of investment that has to be done. I had the privilege of being associated with a very large number of companies in developing low-cost automation along with them. The method adopted, which was very useful, was that they will incorporate me as a mentor into the company. So I am like a semi-employee of that Larsen Toubro, then Godrej, and GKW, Cadila, all these places. It's like a semi-employee. In fact, Godrej had even given me a temporary employee card, so that every time I don't have to renew the employee card for that. So a lot of works were done here in different companies, where I will act as the mentor and some bright, good engineers will be given to me to be trained. Those who are students here, you know that you can get 99% and first rank and gold medal without knowing head or tail of automation, without knowing head or tail of design. So with that percentage, when he enters the shop floor, he is puzzled. That is something he doesn't understand. He understands mathematical steps, solving problem, computer simulation and all that. But in a shop floor now, how to handle this and come out of problems, very rarely that is taught, because most of the engineering college also do not have teachers who interact with industries like IITs. There are most of the companies, the college teachers are not interacting with the industries. So just to give you only one or two examples, because they would have taken a lot of time. This is a life of more than 25 years where various projects were done. The shock absorbers for pneumatic pick and place units in Larsen and Toubro, to develop a shock absorber which is as big as this finger, diameter, length. This is a shock absorber imported from Germany. Why are they used is that whenever we have got a pick and place unit and the cycle time we want to make it faster and faster and faster, that is not an issue. Issue is that at the end of it, when fast it moves along a straight line, it will have a lot of kinetic energy and it will impact the edge, spoiling the maximum speed possible. So this kind of shock absorbers, which were earlier brought by Larsen Toubro from Germany, they will be put at the ends that will absorb the shock, and hence the average cycle time could be increased further. The only problem was that getting them from abroad. So we decided to develop it and interacted with the Larsen Toubro company. And to make the long story short, after developing shock absorbers locally and using the excellent facility of the tool room of Larsen and Toubro, the shock absorbers that were developed were found to be superior to the shock absorbers which he had imported from Germany. Because we had developed a way that there are a lot of algorithms and charts from where we will pick up the things, where there is a standard method of production there. It was amazing. Even the company was quite surprised that, that to an MTech student doing this kind of quality work. Then there are a few more things which I have mentioned here of various kinds of things. They were all very fascinating projects, and there are many more, but I will not go into details of them. Pardon me? Once you have got a few of them made in the tool room in a big good company like a Larsen and Toubro, then to make it a manufacturing product is a small. Then they start making. But initially to make, we did do sort of ethical reverse engineering, where we got shock absorbers of this size from every country available, Japan, Germany, and all that. Everything was cut and studied and analyzed, and then finally, we come out with our own design. And the final results were superb when it was done. In fact, I think that if we had done R&D in India, in some of the good companies, we would have been one of the leaders in product development in the world. But one of the things we ensured was that our license permit Raj will not allow development. It will not allow. So that decade after decade, we getting things imported, which also gives some advantages to certain kind of powerful people. I don't want to name them. They preferred not to develop and import rather than develop in our own country. That was also there at that time. So here, when we talk of low-cost automation, one of the things that is a little difficult to know is I can develop an automation using a purely mechanical system. What is purely mechanical is all mechanical components, as your mechanical students are familiar, the gears, shafts, bearing, cams, lead screw nut, that kind of thing. That is called a mechanical system. I can also develop the same thing automatically with pneumatics, compressed air. there I'll be using cylinders, valves, and pipes, and then a controller to control the thing. I can also develop the same thing with hydraulics, that is oil under high pressure, and it passes through tubes into various parts of the machine, and the system operates in a hydraulic way. Or it can be electrical, where we use either a conventional AC motor or a servo motor, and then use them for the purpose of automation. So the main problem I observed when I was interacting very nicely with various industries was that choosing the right kind of system, either mechanical, pneumatic, or hydraulic, is a very good thing for the company in the long time for getting return on investment. But when they approach the companies which develop automation, there are very few companies where the companies are developing all types of things. So if the company is well known for pneumatics, you know the names of the companies, which are in pneumatic. Festo is one of the well known names. So he will only give a pneumatic solution because that is his area. If you go to a hydraulic company like now, what is it, Eaton in Pune, they will give a same thing, they will give a solution in hydraulics. A third company will give, because each one has their own strength. And moving into an unknown area is not easy. I think that is where I had the advantage, because I did not have any constraint. For different companies, I could try all kinds of things, and that gave a very good idea of knowing which is to be picked up. I think that's a very important thing. Among these things, even to know which is to be picked up is a complicated thing to find out. Choosing the right technology will provide a better solution, because solution everybody will get. But a better solution, that means you should have chosen the right technology. Like from here, if I want to go to city, I can use a two-wheeler, I can use a nice car, I can use a big bus with a capacity of 60 people, only me traveling. So that optimally which I should use becomes important, particularly in the automation area. Electro-pneumatic systems are very common and used extensively. And I have taken an example of a pneumatic, electro-pneumatic system to show you how sometimes very interesting things can come. So whatever I have given here is reading material. It is not going to be covered here. That is, every pneumatic system will have cylinders, valves, pipes, FRL unit, that is filter, lubricator, and regulator units. So all these are given here to show and how they work in different colors and all that, which will take some time to go through them. Then finally the pipes. What is important here is to know the language of pneumatics. This is called pneumatic symbols, accepted all over the world. And these show some of the symbols used. And primarily, Festo is a company not only manufacturing excellent pneumatic, electro-pneumatic things, but they have also written excellent books on pneumatics and electro-pneumatics. So I think that if anybody wants to develop better understanding of pneumatic, electro-pneumatic, I will recommend that read the books by Festo, authoritative books written by Festo. The example I am taking is electro-pneumatics, and very different from the normal cases. Problem with purely pneumatic system is that sensors have large time delays. Once a signal is given to one end of a tube, it will take some time to travel to the other end, the wave of the pressure. And because of the time constant will be very large. Whereas if you have got electro-pneumatic, all the signals are changed from one location to another using electric wires, and hardly it will take any time. So the whole system will operate much better. So if you look at the electro-pneumatics, we are just trying to only get an appreciation of the subject, but otherwise it is it takes time to go into details of all of them. In electro-pneumatics, actuators are same, no difference. They are the same. Valves are operated by electromagnets. So instead of normal pneumatic valves, we will be using what are called electro-pneumatic valves, which will have electromagnets at both ends. then connected to a ladder circuit, and that kind of a control will be utilized by this. These are some of the devices. I'm sorry that, to try teach about all of them or talk about all of them does take a pretty good amount of time. And when we say electropneumatic, there will be this kind of controller where these wires that you are finding are the wires which take the electric signal to the walls, electromagnets of the walls. Electromagnets will move the plunger inside the wall, and when the plunger moves, the compressed air will move from various directions varying, and that is how the electropneumatic systems operate. You can see a relay. The people in electrical and control systems are familiar with the words of what is called on and off contactors. NC is called normally closed contact, that is closed. NO, normally open. So you can see that in this case, very nicely, you have got both normally closed and normally open. So when one changes from NO to NC, the other changes from NC to NO. And this will ensure that the logic will be safe. Both cannot work together because of the physical movement. Either I can have NC or NO, I cannot have both of them. So these are very commonly used in these circuits. Proximity switches are a number of devices whereby the proximity of a moving member can be sensed. It can give a trigger signal to the wall and thereby changing the direction of motion. These things are all various types of sensors available. And the last part is interaction with the human beings, which will be done with the help of a number of push buttons. They are available different sizes and colors. But as used all over the world, red color is to stop, green color is to start, yellow color is to keep a time delay in between. And push buttons also can be used manually. I think that if I want to give you an example of a electropneumatic system, what we developed for Larsen and Toubro will be a very fantastic example. This device, what you see here, it is a electropneumatic system which did not exist before this was developed by an MTech student of IIT Bombay. Before that, it was not there. We had only one photograph from one side in some book, seeing that this kind of thing is possible. From there, we had to develop the whole thing. And what you find in this example is to separate out the springs which are entangled. As you know, high quality springs of better quality materials of high value, those springs are packed well and then come in the packed condition. But low quality, large quantity springs which are used in many of the machines, they are supplied by the supplier in a bag. They are supplied, just like gunny bag, just like wheat or rice, large number of them. So if you tell them to pack it, they will say that the cost of packing will be more than the cost of the spring. Would you like it? Because that is a very tricky thing. So finally, looking at that machine, photograph only, not how it works, we decided that we will try to develop it ourselves. It did not exist. Before that, it did not exist. The basic concept is shown here. There is a drum. Inside the drum, you put a large mass of springs. You know that from a bag, if you take a spring, you don't know whether one spring or 10 springs or 20 springs or more will come together along with that. Then more time you spend to remove the rest of them so that you can take one spring. So it was found that in the assembly of starters in Larsen and Toubro company, the workers were getting wild with anger because he has to put only one spring. More time he spends after taking out, removing the rest of it and putting these again second time. So they told that it will be nice if we can have a spring which does not get entangled. So easiest solution was that, you make the spring near the machine and cut, and it will come out. So there is no entangling. But they have got more than 3 dozen machines. So if you have to make everywhere this kind of spring, it would have been expensive. Finally, it was decided that we will try out this idea. Purpose is you dump a large number of springs entangled inside and then make it work. And what you find here as a tube, this one as a tube, the spring should come out of it like a shot, tuck, 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 like that. They should come out one without entanglement. When it is put inside, they are all entangled. It was a tough job. Anyway, we decided to use drums of different shape. Then we have to put deflector inside so that when the springs are oscillated, they should get at least partially, disengaged. And since this work was done for Larsen & Toubro, we had no problems. Whatever shapes of drums we told them, half a dozen, they will make and give within 3 days. So that was not fabrication was not a problem. And then we developed this simple electro-pneumatic circuits. Electro-pneumatic circuits are, there is a technique by which you can develop circuits of the most optimal value. What it does is that once you put the spring through this inside, this drum is given an oscillatory motion. So all the springs entangled will be also moving with that. And in between you will provide here what is called a barrier. So when this is moving, you put a barrier here, all kinds of shapes. So when this is going on done, they get disentangled. And once they get disentangled, you will allow compressed air to come from bottom here, as is on pneumatic circuits, and which will push the spring through this. So it was difficult to find out a mathematical way of solving it, because compressed air, even though it is nice to talk about them in a pipe or in a cylinder and all that, in this kind of an oscillatory motion with entangled springs, mathematical development was not possible or not easy. So he made a number of drums. He was an MTech student of different shapes and sizes and gave different angles of rotation, speeds, this, that, all that thing with a pneumatic circuit. And this was the electro-pneumatic circuit and this was the pneumatic circuit. And when they are trying it out, and since a mathematical solution is not possible, we had to find out a numerical solution for that. Anyway, thank God. After some operation, when we saw first time after about 8 months, we found that the springs started coming out of the tuck, tuck, like that they are coming. So we are very happy. But that happiness was short-lived because the frequency of their coming was varying, We will be very happy when 6 of them come, one of the thaga, thaga. And then nothing comes for some time. Then sometimes some more will come. Now this cannot be put into an assembly line, this kind of method. Even though we can use a method of a vibratory bowl feeder and store them after they are oriented, partially we can solve the problem. But to solve the problem, this guy has to work. Anyway, without going into all that detail, it was a bright MTech student who did it. Finally, when they started coming out with small variation of the quantity, normal distribution of a minimum value, minus 3 sigma, plus 3 sigma. And that plus minus 3 sigma, we started storing in a vibratory bowl feeder to get a continuous output from the, that vibratory bowl feeder always has a statistical output and it should have a storage to get a quantity output at a constant rate. So this was the final figure. This was the final figure of the setup. When this was made and working, my God, the company was so happy because one of their major problems was solved. This whole thing you can imagine very cheap to make. A few tubes and small things, lightweight things, electronic circuits. And then as many number of springs they had in different locations, developed them and it started working very well. So this was one of the interesting things that was done. As far as the sensors are concerned, I think that probably the current day students know more better than me the sensors. Every day new sensors are coming. So you can treat this write-up about inductive, capacitive, ultrasonic, photoelectric, resistive techniques, which in those days when we talked about, we call them as the ears, eyes, touch, smell, voice, and taste of what is there. Now even there is a wine testing equipment with instrumentation, which can check the wine. Otherwise, earlier it had to be done by manually, human beings. They will put the wine in the mouth, wriggle it in the mouth for some time, and then he decide the grade. And they were very, very highly paid because very few people could do this, grading the thing with the tongue. But now there are chemical I think it is chemical sensors, which is like a tongue, artificial tongue. It will find out the quality grade of the wine, and then it separates out. So instrumentation is making a lot of changes in how they work. I have given also a reasonably nice write-up for those who will like to know about sensors. And when I wrote this thing, we did not have internet. We did not have mobile. We did not have PCs. So all that had to be obtained. But now that this basic information you have got, you can go to the net and find out innumerable varieties of sensors that are available today. And as you may be knowing, some time back, more than, of course, 2 decades back, sensors had to be imported. So that was another problem. Importing the small source sensors, passing through the process was a very painful thing. And I myself had the pleasure afterwards, when my MTech students had to get sensors, I'll give them 500 rupees. Go to the market and buy. Sensors are put just like aloo, potato, tomato. Sensor everywhere. So you will take a bag, kitna, like that, One bag full of sensors for $500. All varieties he gets in that way. So this one change took place. Compared to the earlier time, you have to decide what sensor, then go through the process of importing and writing to the authorities, and all that was necessary earlier. Now it's much better. So in this process, what I have written here is not there, at least in the books which I have seen. If it is there some book, that you are lucky. It shows all the kinds of sensors. Some of my poor MTech students very seriously sat and putting color and nice, or putting lot of effort. They made all these PowerPoints, various kinds of encoders. And in the sensor, only one thing I think I must mention, because this is not always known. The question is that, suppose I want to measure either displacement or velocity or acceleration. Everybody knows mathematically, dx by dt is velocity. D squared x by dt squared is acceleration. So if I ask a question to a student, if I want to measure displacement or velocity or acceleration, which sensor you will use? Logically, you will give a sensor displacement for displacement sensor, velocity sensor, acceleration sensor. Unfortunately, that is not the case. Sometimes I will get a better accurate result of a displacement with an accelerometer. Sometimes I will get a displacement transducer will give me a higher value of the acceleration. Okay? So I think that going into all that details also is a little problematic. This is called an accelerometer, familiar to mechanical engineers. There is a mass, there is a spring, and there is a base. So when you put it somewhere and it accelerates or decelerates, the inertial load on this will vary according to acceleration, deceleration, which will cause a variation to the spring here, and hence cause a variation in the displacement of the spring, which can be used to measure accelerator, velocity, or displacement. Then electronic integration, electronic differentiations are there for getting them further. Another thing, where you find out that sometimes other subjects like solid mechanics can help you in instrumentation is a very interesting factor. Suppose I want to measure a load. There are two methods. One of them is I use what is known to you a strain measuring device. It's a device on which you put a foil. So when it is strained, there is a strain cause. Put it into a Wheatstone bridge, get a signal current and amplify it, and then I will get a signal of the strain. I can also use what is called a piezoelectric sensor, where if you measure the in the piezoelectric device, it will measure the stress and it will produce a signal proportional to the stress and give me a signal. So now the question is, which is better? Should I measure the strain? And from there I try to find out force, displacement, whatever. Or should I use a piezoelectric sensor and measure stress? And once I measure stress, solid mechanics tells me how to go to anything else, like the force, the displacement and all that. These questions come. So you will find that the cost difference is a strain gauge, a good quality strain gauge will be costing now today perhaps around 200 rupees. Piezoelectric starts at 1 lakh and above. So this guy is very costly. At the same time, if I want to measure strain, it is a elastic displacement. So it needs a large quantity and a large applied load. But the advantage of stress is that even if I put a very, very small force, there will be a stress. Any load other than zero will give me a stress. And since piezoelectric elements are very good in sensing the stress and creating a signal, piezoelectric sensors are the most accurate, and they can measure extremely small values of loads and forces and all that. And more important is that even if the speed is very large, this cannot do anything, gone at a higher speed. Where this can go on whatever, even if it is kilohertz and megahertz, it will give results. Just to give you a very simple example in a sentence or two, when one of my MTech students had to measure while drilling a composite plastic reinforced GFRP, glass fiber reinforced plastic with a lot of fibers inside and a base matrix, and he had to drill. So drilling will cut off these various fibers in different ways. And when we use the piezoelectric, it gave signals individually whenever each one of them was cut and then put into a computer. My God. Within one rotation, we were getting 100 or 200 values of stress and strain. Unimaginable, this capability. I was amazed and got more respect to piezoelectric sensors than the earlier days. Then, if it were class, this is very convenient for teachers to show graphs of what are the important factors. It is the poor students who have to remember it, not easy to remember. At least till the exam time you have to remember, then forget it, about that. But for teacher, it's very easy. Graph, this, that, all kinds of things, important factors can be explained with graphs, and if required, also a tabular column below that for the purpose of comparison. Well, selection of sensors, I have to do very large number of time in my low-cost automation activities. And one of the way I used to do low-cost automation for various, very large number of companies, right from one end of India to the other of India, it was because of the fact that the undergraduate students are not taught either instrumentation properly. Properly means not to write answers and get marks, but real understanding like this, what is the influence of each sensor. Not taught machine design adequately to look at what is to be done. And so we found out academically that even the students of the best grades, who are taken obviously by the companies because they are the best in academic performance, Once they go to shop floor, they fail. Absolutely no idea, head or tail, what has to be done. It is said that one should always make use of the opportunities, when they come. So I was very lucky. My role was to go to a company where there are some nice young engineers, all 99, second rank, gold medal, blah, blah, all kinds of things. He doesn't know head or tail of design. He doesn't know head or tail of instrumentation. He doesn't know head or tail of servo systems and how to analyze them. Great. Then the company will say, isko jara sikha do. Then I will be a mentor, telling them how to analyze, then give projects in their own company. You do this, then comparison. So after a few months of mentoring, they will be able to develop the things. So this was one of the activities I really enjoyed. Getting the best students whose understanding of these subjects were zero, in spite of getting very good academic performance, but not adequate for solving problems in the industries, complex problems of automation in the industries. Last part, I think many of you are from IIT, so there is no point in showing to you. We have got a workshop which is used for all this development work. This is a hydraulic power pack, which is one low-cost automation using hydraulics. This is the power pack which provides supply. This is the press. And even though this guy looks so small, it can apply a force of 5 tons. 5 tons it can apply. And if I want this to apply 10 tons, I can make it stronger, use another power pack, it will give me now 10 tons. So that way it is easier. This is a pneumatic bending machine that is there in the workshop. In a similar fashion, instead of hydraulics, if I use pneumatics, yeah. So here you put a sheet and then use this electro-pneumatic switch. It will hold the workpiece here with an electromagnetic force. And there are these pneumatic cylinders as shown here at an angle. They are controlled by supplying the compressed air as a supply into the system. This shows all the systems that are put inside. And afterward, they can bend the sheets in whatever shape you want. Anything from a small thickness of 1 or 2 mm to much larger values of larger. Then this is a wooden turning lathe where, because it is wood, it's easier to operate and get a control of various odd shapes and make them. So I think that this much is what I can show you, and I will try to take out an example and try to see how you think about it, okay? Probably that is the most fascinating project I have ever done in my life. Am I boring you or it's okay? All right. The problem I had to solve was like this, that a company in Ahmedabad, they manufacture syringes. Coming?
To open that Erixa project to
Which one?
Erixa project, do you want to present or something?
No.
That's all.
This will be, they themselves will get percent. Thank you. I think that among the whole variety of projects which I found it very fascinating was this project on injection syringes, needle and syringe. And for I don't know today, but in those days when I did it 10, 15 years back, the diabetic patients had to use injection every day. They themselves will do the injection. And the size of the stainless steel tube used was 27 gauge. When you say 27 gauge, the size is like this. The tube has got outer diameter 1 mm obviously the wall thickness is 0.1 mm. This is the wall. And then when this is to be ground, you have to grind on this 0.1 millimeter 5 angles. This produces the needle. The 5 angles are required in this wall. In this circular thing. 5 angles are to be provided. And what they wondered was that whatever needles were produced, एक मिनट ये हाँ ठीक है ठीक है they found that the needles produced in Ahmedabad that time 15 years back, they were giving more pain than the German and Japanese needles of the same geometry, same parameter, everything 27 kg. So the company told me, okay, you are a man of metrology. These are the problems of angles which gives pain. Solve it. You are an expert in metrology. I was not expert, but people thought I am an expert, in those days. That is what. I was very embarrassed, I can understand angles and connection and all that from a metrology point of view, but how do I connect it to pain and reduce the pain? So, as usual, reverse engineering got needles from Germany, Japan, various countries. So, when they are used on voluntary patients, whenever it is German or Japanese, the patient will not give any problem. And the one which was produced, enlarged and viewed through a computer, looked very similar, angle and diameter, everything was okay. But the moment you try to inject, the patient will scream because the tip was a little thicker than what it should be. It will hit the muscle. And then when he pushes further, the fellow will scream, unable to control the pain. So you reduce and made it more narrow. So that is not. So when it is injected, the patient doesn't weep and you are happy. But then because it is very thin, while going in, it has got bent inside. So when you take it out, double sound, he will scream. So the only question is, does he scream when it is inserted, or does he scream at twice the volume when it is being removed? This was the problem to be solved, Connecting the angle with pain was a very difficult job. But there was one thing that was available called a simulated skin. Like everything now is fashionable to do simulation. So they had developed, that is the ISO, International Standard Organization, had developed something similar to a human skin. So that when this penetrates, if the penetrating force is 25 milligram, then it should not cause very much pain. And if it is more, then of course it can cause pain. But unfortunately, we found that all the ones, Japanese, German, and our also, none of them, the penetration force was more than 25 milligram. But only ours was causing the screaming in that process, Anyway, I think that it was a very big challenge to me, I got very embarrassed. Supposed to be good in metrology, and there are 5 angles and also in the stainless tube. Don't know how to connect pain with the angles. Anyway, it took more than 8 months to solve, and I am glad that finally we could solve the problem. And then someone came and took away some of the things we had built. It needs a ultrasonic vibration to remove small particles of dust or stainless steel part inside. Otherwise, when the injection is done, if it gets into blood, sure I will be get arrested, for lack of designing and safe devices for that purpose. So this was the case. Anyway, after all trial, it took more than 6 to 8 months. It was a miserable time. I was always desperate to find out a solution. And when finally got a solution and produced some half a dozen of them. One fellow came and took away all that, this 1 millimeter wala, but it's gauge 27 for diabetics. I told, why are you taking, I am still studying. No, the owner of the company says, I want to be the first to test his tube. That night I could not sleep. He himself was trying on him. How is the new living thing? By God's grace, anyway, it did not give any problems and that could be solved. So sometimes what I would like to say that what is called a locus automation, many times it is not a problem of a automation. It is a problem of understanding what is the problem and how can we come out with a solution for that. I think that I can, if you want, give one more example and then maybe we can stop. In one of the companies, one of the Godrej company, there are 22 companies, so you will not know which company I am referring to. So sheet metal is given powder coating. There are two methods of coating. One is called spray painting. Second is called powder coating, and both are similar application. One is solid, other is liquid, compressed air. But nowadays, more often we are using the powder coating because that is stronger and it will last longer and so on. So when the pick and place unit goes on spraying onto the sheets which moves over a conveyor belt in that company, lot of the powder was escaping because now one plate is here hung, another plate here with a gap, third plate below, from here to that height. So when this guy is spraying, in between places also this continues to spray. So they told that, can you develop some system that as soon as the plate goes, this will close. As soon as the next plate comes, it will open. And like that, an automation, whether it is possible. It was found to be extremely difficult. Anyway, to make the long story short, it was found that optimizing the pressure of supply regulation and the speed of rotation of the conveyor belt, which they had set it, whatever was they set by the company, we modified it to suit the thing, the problem could be solved, and whatever fabrication was done in those days, more than 50 years back, only cost us 10,000 bucks, and the saving of powder every year was more than 1 lakh. Just 10,000 submission, because this powder is there in every shift, first shift, second shift, goes on powder. A lot of powder was not usable after that, so that waste was there. So in conclusion, I can say that is any automation a problem of getting things moving with machines and system without human being, or is it that first we have to understand what is the problem and then come out with what is a possible solution for that. I think that is the crux of the locus automation problem. And second part is that decision making. Should I use pneumatics? Should I use hydraulics? Should I use mechanical system? Or should I use electro-pneumatic, electro-hydraulic, pneumo-hydraulic? My God, the hybrid version that are available are so large. It takes some time for one to go through them and pick it up. Anyway, that was a wonderful experience. Like if you check about the quality, you may not be aware how much one has to do for exporting. So there is, in the car there is a seat belt, a driver and the person who sits next to it puts a seat belt. Now also there are the bags which will open out and protect the worker. So the question was that, what are the tests to be done on a seat belt? Some of things very clear. You apply a tensile force, when the belt breaks, you know what is its tensile strength. Second thing is that you go on applying alternate. After some time, due to fatigue, the belt failure will take place. So that is the second test that can be done. So after doing these two tests and getting some information, when this was a company in Bangalore, when the one party came to export this and looked at this test, They told that no, unless you test reliability, we cannot. And reliability results of each belt should be attached because it is produced on the computer. So ultimately, we have to go back. We have to find out how to measure these forces, both static and dynamic, and then record them for each of the belt. And then when this is pushed, for the handle, how does it affect the action of the belt, and how a body dummy is put in a vehicle and then suddenly it hits a wall. What are the different kinds of the motions at high speed the dummy takes to see whether any part of the body may hit some part of the vehicle and then get damaged. It was a very interesting project, and some of the younger engineers in the company, they went on developing these. I was something like a mentor all the time. I was like a mentor only. And finally, when the system was developed and when they came, the company came and saw what are the testing facilities we had elaborately arranged, they were very pleased and they got the export order. That is a very satisfying thing that comes. I think that in future, since we are trying to say that we will have to do self-development for army and our air force and other things, defense systems. What is the most important test for them all is the reliability test. How reliable is it? Because at the time expected, if it doesn't work, there is nothing we can do that. The problem of reliability test for anything is that the reliability test, there are no equipment available. Because every individual product man, he has to develop the reliability testing facility. I think that if we move forward, and as expected and hoped now, we are going to become a global supplier of manufactured components and all, we will have to learn how to develop various kinds of reliability tests. I will show you one simple example of the reliability test of a scooter switch for the light. For a switch of a scooter light, it is nothing very critical, so to say. It is not which is very critical. But when it had to be exported, the various tests done were, in the first place, it used to be put to 50,000 times on off to check how long it will work. It works, okay. Then it will be taken to second chamber where there used to be dust particles artificially circulated by compressed air. Again test. If it worked, third chamber was salt water spray. Again test. So like that 4 or 5 different places when reliability test was done, and the end result is the switch works, then you can give a report that its reliability is acceptable, and then it can work. Do you have that lock fatigue testing figure? Yes, see. This is one interesting thing, I would like to tell you. Of course, a lot of things I developed for reliability tests because they are not there in the market. The company has to develop it. That door lock of opening and closing for reliability. Yes, see. Door lock reliability is the thing. Yeah. Fatigue, that must be the one. Testing the door lock. Yeah. That is it. That's it. That is the one. Yeah. Thanks. This is a door lock, as you can see, the figure. That is a door lock made by a company in Bombay. And things were going on well when they were selling it in the country. Then they became ambitious and wanted to sell it abroad. So when they wanted to sell it abroad, they told, we want reliability data. What is the reliability data can be seen sequence of operation. First operation is inserting the key into the lock. Second thing is turn the key to open the door. Third thing is turn the handle after the key. Then fourth is open the door. 5 is release the handle. 6 is close the door. 7 is turn key to close the lock. And 8th step is remove the key. All the operations of opening and closing was to be done in this manner. So when you sell it in India, nobody will ask for this thing. But when you wanted to export, it had to be developed. So what the company initially did is that because automating and all become very complicated.
Just a question, how many times they ask?
50,000.
Even the lock and
Like that, this whole sequence to be done 50,000 times without any failure. Then they accept it is reliable. So that is what we had to develop within the company. So as the first step, the company employed 6 people and got 6 dummy doors and locks and all, kept one after the other, 6. And they employed 6 daily wages saying you go on doing it, taka 1, taka 2, like that you go on till 50,000. So I think after the first day, hardly anybody turned down for that work because going on doing it 50,000 times is very troublesome. And also the human beings have got temper. So first time in the morning you are fresh, you may do very carefully. After some time, lunch time and all over, you will be tired and you will be irritated sometimes. And if you are a strong person, the force applied, pulling, they all will be variable. And you have to prove to the export party that everything is done in a uniform speed, uniform force and so on. So since I am very familiar with pneumatics, what we decided that we will use pneumatics because one of the advantages of pneumatics is that pressure is constant and if I control the flow rate, velocity also will be constant. So every step that is done will be at a regulated force and at a regulated speed, not depending on the strength of the worker or the temper of the worker. These things will not come to picture.
No, but in actual deployment,
Huh.
humans are operating.
Pardon me?
In the actual deployment, humans operate the door. So at that time, the forces will actually be varying.
Yeah, but whenever we do reliability test, that time the data has to be produced at a steady values. And if this succeeds, then the possibility of it failing by a human being operating may be less. That is the thing that was done. So as you can see here, it was very easy to do now. Instead of 6 people going on doing it morning to evening, you put only 4 cylinders and valves and controls, and this will go on doing one after the other. Duplicate it 6 times and 1 person. So 1 person will be going on 1, 2, 3, loading all the 6 or 10, I don't recollect now. And then he is free till something either reaches 50,000 or breaks. When it breaks, it will give signal, or if 50,000 is over, also it gives a signal that it has worked out and done. So now the problem became so easy using pneumatics because the forces, control, velocities, pulling, pushing, everything was at controlled value. And I think that in future, since everybody will ask for fatigue testing or reliability testing, whatever is called. Suppose we now talk of the automobile. what is the difference between impact test and endurance test? Two tests are to be done satisfactorily. What is the basic difference between endurance test and impact test? Endurance test is to see whether when the vehicle goes on moving and dynamic load acts on all parts, including the bearings and engine and shafts, will it lose its quality? Will something get loosened up in a bad road? That is the test of endurance. That will be done. And shock test, as you know, you allow the vehicle on a rail to go and hit a concrete wall at a speed of 130 or 160 depending on the vehicle. And if the vehicle is high speed, you will go to beyond 200, 250 and it will hit. And then certain parameters are checked whether it is safe against impact for human beings. These are the two tests that has to be done. So earlier days, when I went to telco, they had the endurance test done. They created an artificial road of all bumps. And then when the vehicle is taken around, the whole time the driver will be jumping. And after 2 hours, he can't bear it. So they used to put two drivers and one will do 2 hours, then he will get down and take rest. Second one will sit and another 2 hours. This was the way the endurance test was done. And as far as I know, the shock test was not done. And last month, Government of India has decided that in future, all the cars should be put to the impact test. They should be put to impact test. This is a new decision that after 31st of October, now we have got into the November, now onwards, the companies who manufacture cars, they have to get it tested. Endurance testing, they anyway do. Like Telco has got an endurance track within the company. But so far in the impact test, they did not have the facility. So now government has told no, that test also you have to show it performs and against the impact, the people will be safe. That is what it is done. So what I have done probably is to show you a number of different types of problem that can come, right from the needle of a injection nozzle to reliability of a door to needle, there's a road and impact test of vehicles, which now the government has asked there is an institute of research in Pune. They have been asked to develop the standard procedure so that the companies can either get it done there or they can develop, if it's a big company, their own testing facilities. So I stopped at this point, and in case there are any queries, I can answer them. Otherwise, we can leave it at this stage.
One more thing. For this problem, the forces are low and so this pneumatic system, will it achieve that precision? Because for pneumatic, usually you need to apply sufficient pressure, right? Here you just have to turn and also it has to correctly go inside the hole.
It depends on the regulator that we use for pneumatics. Because the pneumatic system all over the world, 6 to 8 bar is called the high pressure, 6 to 8. And 4 to 6 is called medium. And anything less than 4 is called low pressure. Whereas if I go to hydraulics, starting point is 50 bar. There is nothing, anything below than 50 bar is called low pressure. 50 to 200 is called medium pressure. And beyond 200 bar, it is called high pressure. Okay, so for pneumatics, there are regulators which can control fine. Like, I do not know whether you are aware of it. Suppose I take a crankshaft of an automobile and want to check the tolerances of all relative values. I don't use electronics. I use a multiple pneumatic setup. So you put it in, open the air, all the values will show whether anything is going into the red range. If not, all the tolerances in the total system is okay. So that's open and close and see the values. So there are certain areas the pneumatic systems are good, and certain areas where we cannot use electronics, like if you have got a combustible gas or radiation from nuclear plants, we cannot use electrical system there. We have to use pneumatics because that is the only safe device. Similarly, when I worked for explosive company in Vellore, Tamil Nadu, Vellore, they have a company which manufactures dynamite, for testing. So there also the safety measures have to be extremely, and the workers also will sit quite far away. And instead of one big factory, the factory is divided into small 10 of them. So even if a burst is there, only 1/10 will go. You will suddenly hear a noise, but only 1/10 gone. Remaining 9 are okay. Like that, alternately they will go on repairing and maintaining that system. So these kinds of if you the cooking gas, to check whether there is a leakage when it is being manufactured in the pipes also, they have divided the ceiling into multiple areas, and there is what is called a chemical nose, because when the cooking gas gets into that liquid, its color changes. So you know that there is a leakage. And then it will inform the people and provide safety for the whole system. That is anything else? I think that if we want to become self-sufficient in defense manufacture and also become a global player in manufacturing components and products, we have to be very good in developing reliability systems. Because usually we do not have reliability testing. You might have seen, you go to a company, at the end of the assembly line, it is put to some test, whatever is acceptable, and then they put OK, testing is over. That is only quality testing. Beyond quality testing, no reliability test either. 99% of the products in our country, so none of the advanced countries accept our products. Only some small countries accept our products because they know that these people do not do reliability tests. We don't do reliability tests. Anything else?
Yes, whatever sir is saying in this matter, we are saying that for all aeroplane and everything we are importing, the same product is manufactured in India also. But Indian products are not giving the reliability. But that is why their product is to be imported. Because in aeroplane or helicopters, reliability is the most important factor. What he is saying. Or aerospace component. There are adjustment to a helicopter, but there are 1,000 components which is to be indigenized and done. But everybody has to prove their reliability, what he is saying. So it is very important not only the testing of the component, but the reliability of the component has also to be decided. Thank you very much, sir.
It is my pleasure. He is a very experienced man who has done a lot of activities of developing new products, and he is also fully aware of the importance of reliability testing in these matters. I hope that in future we will have more of such reliability testing facilities within. Ideally, each company should develop their own reliability testing facility, just like this lock I told about, needle I talked about, how to improve the performance. So every item that has to be done. So in case there is any more queries, please let me know. Yeah. I could not hear you fully, even though I am wearing my ear. Yeah.
they are they require a lot of destructive testing.
That's a very interesting question, you know. Do we have to do destructive testing, or do we have to do what is called a non-destructive testing for reliability? One simple answer, you know, which you might explain is that the automobile story I told, that the impact test we do for automobiles damages the car. So that is a destructive test. In a similar fashion, taking some samples out of a total number of cars and putting them to endurance tests, which is more common, you know, you will make a track and go on doing reliability. That is a non-destructive testing, technically speaking. So some of them will be destructive and some of them will be non-destructive. But if it is non-destructive also, one is supposed to take statistically some amount of samples. I don't know the lot size from how many, how much. And they have to be put to destructive test after that.
Okay. Sufficient samples.
Yeah.
Say, now many Indian standards you will find routine test and type test. So the type test which is done is for reliability. Because your product has to pass through all tests. But you have not to do those tests every day. The routine test to be done every day. But type test is to be done periodically. So this is defined in Indian standards also. Many standards, particularly in plastic standards, they are defining.
But does Indian standard align with the international standard?
There are many Indian standards which is better than the international.
I think that this also, yeah, please, you finish, then I will.
Yes.
I think that one of the things you all might be, or it is better to be familiar, is that there are international standards like the German standard DIN, American standard ASA, and ISO, International Standard Organizations. So we used to be proud that our products meet these requirements, any of the standards. Then we say that it is good. But now, starting from Japan, particularly the Toyota company, they told that that is not enough. This testing is only getting a pass grade in the exam, whatever they call. So you must have what is called a quality manual. You must have your own quality manual, and you have to show and prove to the authorities that whatever you have written in your quality manual, you are testing. Now you are put in a real problem. Because suppose I make a car, she makes a car. So I make a quality manual for my car. She makes a quality manual for her car. And the engineers can easily find out which of the two quality tests are better. That means if mine is bad, my business is gone. And if I try to cheat, which we are very comfortable, there will be severe punishment if you have not followed the quality manual which you yourself have written. So it has now gone out of that zone and your own quality manual. And that puts tremendous pressure because every good company will be trying to do better than the others and to come out with a better quality manual. Sorry. Just to give you an example, if you want to see what is the test done for the tire of an airplane, this is taken to a height which has been calculated, that tire. And with rotation, it is dropped from that height to the ground. And they have calculated that this will be the maximum impact load the wheel of a plane may have to face while landing, even in the worst case. It has been calculated. So every time you don't have to use a plane to test, you take it to that height. This is available in the internet. Drop it in rotation. It will come and hit the ground, and then they will find out how it has behaved.
And modeling and simulations, is it accepted as a possible alternative for this destructive state?
I do not know, because the main problems of simulation is that a number of things you cannot get into simulation. Suppose I make as a mechanical man, suppose I make a gear of a particular steel, and then I do simulation where I'll give the properties of the material, Young's modulus, the strength and all that. But a real steel will have variations of these things at different locations. And that the simulation will not be able to. It will assume it to be perfect. It will assume geometry to be perfect, which is not the real thing. So as far as I know, simulation is a good one to come to the better possible alternative in design. I simulate one, second time, third time. I say, now this design seems to be accepted. But after that, physical testing has to be done. Many parameters we can't incorporate in that.
Thank you so much.
Thank you. If any more queries is there, I'll like to answer. Otherwise, I don't think there is. But I think that now, since the government of India says we should be self-reliant on the defense manufacture, there is a lot of scope for what are called startup now. You know, a young bright man starts a company. So if they develop a method of checking out some important parameter of some part of a defense thing, I hope that it will be accepted or it will be taken care of by the defense department. That is what I feel. Till now the need did not arise, so we did not do it. But now that the need has come, we will have to do that. Okay, thank you all for the patient hearing. I am very, very fond of this area of low-cost automation, and being a mentor and working along with the engineers of many companies, you know, it was a wonderful experience. You know, it is as if I worked in many companies, even though I never worked in any company. Thank you.
Professor Joycee is not there. I think the PhD student Tom is going to show some of the demo. Please.
I'm a PhD student under Professor Joycee Mekie, and Shrey is a BTech student. So here today we will be demoing a small BTech project that shows a hardware accelerator, a low-cost hardware accelerator that can infer any neural network that a user designs with deterministic timing, meaning for the first inference, if it takes, let's say, 10 milliseconds, the second inference will also be 10 milliseconds, and the 100th inference will also be 10 milliseconds. So this is quite crucial for manufacturing, where let's say you are having a pick and place equipment, and let's say there's a camera that detects defects, or let's say it could even be identifying a bad apple, right? So when the conveyor belt is moving forward, if you want to know exactly what fruit has to be picked, then the results have to come at the deterministic timing, at the constant timing, for the mechanical aspects of the system to work properly. Okay, so here we are going to not have a lot of sensors or anything to show. So we have a small board over here which does the deterministic computing. Okay, so what we are going to do is, using the computer that's connected to the projector, we are going to inject an image into the board, and it will basically show what kind of an image it was. So we are using a standard test called MNIST, and the reason for the demo is not to show how good the neural network is. So any user who has some experience with the neural network can design their own neural network. So if your neural network has an accuracy of 99%, 100%, that will still work here. Okay. So the design aspect of what is processing is more important, and we will show some aspects of it. Okay. Yeah, so I think we'll have to wait a bit to see it in action. It's already running, right? You can start.
The HDMI is connected, but it's not.
Did you try this?
No, I will try.
Yeah.
So this was the demo that we are showing today is part of was something that we submitted to the VLSI design contest that happened last year in Hyderabad. So what we were trying was, people would be buying low cost equipments, and one of the key criteria that we would like to explore is how much benefit we can extract out of that equipment. Can we reduce the latency at which we process using that equipment? And many times for foreign nationals or foreign companies, such resource limitations are not a big thing. They can buy, FPGAs that cost, 8 lakhs, 10 lakhs and run their thing. But let's say if you want to run it on an FPGA that costs maybe 10,000 or even less, right? Which you can, acquire from the market for very low cost, but then can the actual neural network work on it? So what we observed was, traditionally what people do is they burn the chip, as in like they make the chip maybe in 1,000, 10,000 and use it in their manufacturing cycles. But for a regular or a small or medium enterprise, this might not be possible. They will have to come up with, quote unquote jugaad ways of running things. So what we found was, even designing it slightly different can ensure that we can even get 3 to 4 times throughput compared to how the foreign nationals do it. Okay, so here what's happening is that I have slowed down the operation so that we can see an image. Right now only, it's an MNIST image, meaning digits that were used to decode post. So someone would be writing, the pin in your letter, right? So earlier there was this problem that people will be writing the pin and it's all sort of handwritings, and you would like to automatically sort the letters. Okay, so you have to identify what each letter is. So this is a small neural network that does a first job of doing it, and we have implemented that neural network on the design that we have. So the neural network is not of high quality, but the operation is deterministic. Okay, so some image would be done. It's also throwing out a lot of intermediate results, and it will also predict what kind of image it was. So the previous prediction was correct, this one was wrong. Okay, it's a neural network. It can be right, it can be wrong with some accuracy. Yeah, so that is the demo. And this kind of implementation is very important in the following sense. Sir has already said that the importance of having sensors and the knowing what all are the nuances associated with it. So now you can go to the market, buy sensors by the bunch, right? So but are they themselves identical and uniform? Okay, there will be tolerance issues with them, and we have been hearing that AI is very good at so and so things. And one of the key benefits of using artificial intelligence, which is not the right term to use, or let's use the right term, machine learning. When you use machine learning, even if your sensors have some variations, the machine learning algorithms are usually robust enough to still handle the input and make the right actions that you require. Now, when you employ it in such a scenario where it's a production line or something like that, you might need a small low cost board like this. Okay, maybe something like 10,000. This board I think costs around 17,000 something, right? You can even purchase something even even less costly and install it in your production line. You could have a camera hooked up to it. You could even have a display hooked up to it, so to see what kind of statistics that come out of it. And then you can have actuators connected to these small holes. And earlier there was a pneumatic controller that was there. So those pneumatic controllers could themselves be powered, or so not powered, controlled with these signals. And a human-like actions could be taken. And yeah, so there is this opportunity. So you do not have to invest in lakhs of equipment, especially in like heavy GPUs, computers that cost a lot. A simple equipment like this connect with a small display out connecting to your controller or the relays could get your job done and could lower your cost by a lot. Yeah, I think that's the demo. So we will be taking questions. Anything, I mean, regarding AI, ML on production, how to reduce costs, or if you want, high performance.
It will be good at edge detection.
Yeah, so there are two aspects to this. The first aspect is the software about it, as in like you can build neural network models that perform really good. So this small frugal hardware can even do state of the art neural networks like ResNet or Google's variations of it. So if it can, so ResNet was built to identify 1,000 different things. So as in like you give it an image, if it belongs to any of those 1,000 different classes, it could be a horse, car, or it could be modified to, let's say, go from really good nuts, springs, whatever it be, versus slightly defective. Then defects that can be corrected or not. All that can be tuned into it, and that can run on a piece of machine like this, and it will be it can do it at a rate of, let's say, 1,000 times a second. Yeah, and even if you get a GPU that is many times costlier than this, it will actually take more. Yeah. Yes, and to answer it precisely, yes, it can do much better than edge detection and edge detection also. Yeah. Um,
Yeah, what is it looking at right now?
So right now, there is a standard benchmark. So imagine you had sensors, okay, a small camera that takes picture of handwritten letters, okay. Now imagine somebody did that work for you and has stored it. So I have stored all that in a file in my computer, and instead of the camera giving that signal to our processor over here, the computer is injecting that image.
Okay.
Okay.
So right now nothing is coming from. It's just for showing to us.
Yeah, it's just for showing to us. So if we had a camera and hooked it up and gave the same signal of a handwritten, let's say 6-9 postal zip codes, then it would infer and tell what it is. Now, this has been made to demonstrate it works, rather than saying, okay, we have got a high good neural network. That's not the goal here. Okay, so if you go to, as sir just said, can it do edge detection? Okay, if I go to a separate company, they might be asking for proper segmentation of the entire image into 5 different parts, not just the edges of it. Okay, so depending on the user or the application, the requirement will change. So that's why we decouple the hardware aspect of it and the software aspect of it. The software aspect of developing a neural network these days is very trivial. You ask an 8-year-old, make him watch a 1-hour video and tell him to do it. This can be done. It has become that easy due to all the
Available content.
frameworks that are available to us right now. And once you do that, then you pass it through our software, then you can basically make our hardware do the same thing. And when you are developing it, you are using your computer or a GPU, or let's say if you are into the cloud thing, then a GPU or a hardware accelerator at the Google sent or Amazon sent. But they will take different time each time you infer. This is deterministic, meaning you can deploy it where operations are very critical and it should be real time.
So where did you buy this one?
So at IIT we have a couple of these and I think 50-60 of the smaller boards. Yeah, so our BTech students actually get trained in designing circuits and small systems on boards like this, and you can think of it like you have seen ICs, right? Yeah, so our BTech students in second year gets trained to design small ICs, and they test and see if that design actually works on a board like this. So this is known as what is known as FPGA. And I think Shrey, you want to say a few as to how it will be? Yep.
So basically, this one is the Nexus board, Nexus 4 DDR board, and what we BTech students work on is somewhat smaller boards like basis boards, because we don't have to particularly deal with such bigger architectures. So in my second year, we implemented some computer architecture like a cache controller onto an FPGA, and such projects are helpful when you are trying to understand how on the hardware level are things working out, and if you want something to be implemented on the hardware level, then FPGAs are the best tool to start working on. That's why we are trained to do it in our second year digital systems course.
Yeah. So let me precisely answer the question. You can buy it on Amazon.
Okay.
Okay.
Okay. Thanks.
Yeah. Sorry. Yeah. Excellent presentation and thanks for the answer. Thank you.
You are going with the CNN model.
Yeah.
On the software, yes, I know you said you are not as of now worried on the software side of it. Are you planning to go into vision transformers?
So we are basically providing an API in which, just like let's say TensorFlow or PyTorch, where you can define your neural network and the hardware accelerator will process it. So that's why I said we can do any neural network.
Yes.
So anything that has convolution, anything that has, let's say, when you said transformers, it's matrix multiplication or a vector to matrix multiplication. Yes, the hardware can do it. It's optimized for that.
Yeah, and also are you getting onto the model explainability, transferability, because that becomes more important now.
Yeah,
when
so
you're
basically the number of cycles that once you define it, as in like the neural network, the number of cycles that will be required to process that neural network will be deterministic and will be fixed. So let's say if it takes 1564 cycles,
Yeah,
it will be 1064. That cycles.
okay.
Yeah.
That's one side of it.
Yeah.
Right? Perfect. Other side of it is how the model is learning what it is learning. Are you looking at that as well?
So this is the inference accelerator. Training and inference requires different kind of requirements. Training can be done offline in most cases. Okay, but if you want to incorporate training while inferencing on the fly on a shop floor, that could also be incorporated to this. But yeah,
Excellent. We'll discuss that. I think
Yeah.
something is interesting. I'll speak
Sure,
with
sure,
that.
sure.
Yeah, thanks.
You
Sir?
can ask the question, there is no problem.
Okay.
Sure.
That's fine. I think we can discuss, and it's really nice because we have some work discussion happening with medical fraternity, and we wanted to have tuberculosis X-rays and all those things studied well, and we have been doing literature reviews, and where CNNs, ResNets have been used, but as you say, the chat GPTs and that have come, the transformers models are picking well. So that's where we are looking at the vision transformers. Probably we'll discuss that.
Yeah,
in
sure,
detail.
sure. So see, the thing is, it's always where you are deploying. I sort of do, my research is focusing on what would be the right kind of accelerator or the compute element for the kind of job that you are having.
Right.
Okay. So if you are having a mobile phone, the kind of power envelope that you have versus the if you are running at a shop floor where you could potentially even have a supercomputer facility there, the requirements are quite different, your constraints are quite different, and then the neural networks that would get your job done will also be different, right? And of course the reliability, the accuracy that is required for that, all that differs. So depending on that, identifying the right accelerator is one pillar of my work, and then developing new accelerators where things do not exist or when they do not meet the constraints for a particular application. So in that context, when you ask this, we'll have to first look at the application as to what it is.
We'll discuss.
Maybe it might be the case that we do not even have to go to a transformer. It might be doing a bit of fine tuning to get to the accuracy that you want. Maybe the situation demands that. We'll have to look at this, and it's on a case by case.
Sure,
Actually,
no, that's fine. Understand. You're working more on the hardware side of it. You're working more on the hardware side of it.
We do both. We
Yeah.
do hardware, software co-design for the application.
Understand.
Yeah, so I think you are familiar with the term and then you
Right.
understand. the rest.
Understood. Thanks. Thank you.
Thank you.